Hi friends, welcome to all. In this video we are going to see the lab activity configuring VLANs and trunking. Before coming to this lab activity, friends, if you are watching my channel first time or if you have not yet subscribed this channel, consider subscribing. Also enable the bell icon near to the subscribe button so that you will get the notification message when I upload the new videos. Here we can see our addressing table. Also objectives, we will go through that. In part 1, build the network and configure basic device settings. In part 2, create VLANs and assign switch ports. In part 3, maintain VLAN port assignments and the VLAN database. In part 4, configure an 802.1q trunk between the switches. In part 5, delete the VLAN database. Also, we will go through the background. Modern switches use virtual local area networks, that is VLANs, to improve network performance by separating large layer 2 broadcast domains into smaller ones. VLANs can also be used as a security measure by controlling which hosts can communicate. In general, VLANs make it easier to design a network to support the goals of an organization. VLAN trunks are used to span VLANs across multiple devices. Trunks allow the traffic from multiple VLANs to travel over a single link while keeping the VLAN identification and segmentation intact. In this lab, we will create VLANs on both switches in the topology, assign VLANs to switch access ports, verify that VLANs are working as expected, and then create a VLAN trunk between the two switches to allow hosts in the same VLAN to communicate through the trunk, regardless of which switch the host is actually attached to. Here we can see the required resources for this lab activity. 2 switches, Cisco 2960, then 3 PCs, Windows 7, then we require the Ethernet cables as shown in the topology. Coming to part 1, build the network and configure basic device settings. In part 1, we will set up the network topology and configure basic settings on the PC hosts and switches. Step 1. Cable the network as shown in the topology. Attach the devices as shown in the topology diagram and cable as necessary. Also in step 2, initialize and reload the switches as necessary. We will build and connect this topology on this Cisco packet tracer. 2960 switches, then the PCs, and now we are going to connect these devices. Copper straight through, fast Ethernet 0/6 to this PC, fast Ethernet 0/11 to this PC, fast Ethernet 0/18 to this PC, copper crossover, fast Ethernet 0/1 to fast Ethernet 0/1. Right. We will rename these devices. This is S1. Here we have S2. This is PC-A, PC-B, and we have PC-C. Also, we will label these port details. This is a F0/1. This is also F0/1. This port is fast Ethernet 0/18. This port is fast Ethernet 0/11. Then this port is fast Ethernet 0/6. Now we will highlight the VLANs. different colors. Then leaves other colors for this. Then here also. Right. You can adjust all these. Here the link between S1 and S2 should be trunk. Here is a VLAN 20. Name is a faculty. This is a VLAN 10. Name as a student. We can see the same VLAN here also. So this labeling will help us to do the configuration without making any errors. Right, now we will come to step 3. Configure basic settings for each switch. Console into the switch and enter global configuration mode. Copy the following basic configuration and paste it to the running configuration on the switch. Here we can see that. We will copy these commands. And we will keep it on a notepad. Coming to S1, CLI. Enable configure terminal. Here we are going to paste those commands. Coming to S2, CLI. Configure terminal, and here is those commands. Coming to C, configure the host name as shown in the topology. Coming to S1, host name S1. Coming to S2, you will set the host name as S2. Coming to D, configure the IP address listed in the addressing table for VLAN 1 on the switch. Coming to our addressing table, here we can see device S1 and S2 with its IP address. Also we can see the subnet mask. Here we will copy this S1 IP address. Coming to S1, we have to go to the interface VLAN 1, and here we are going to set the IP address. Here is that. Then the subnet mask 255.255.255.0. We will give no shut command. Here we can see the IP address of S2. Coming to S2, interface VLAN 1 IP address, and the subnet mask 255.255.255.0. No shutdown. Coming to E, administratively deactivate all unused ports on the switches. So coming to S1, here we can see here we used 2 ports, faster Ethernet 0/1 as well as 0/6. So we will deactivate all other ports. Coming to S1, here we can verify that using show IP interface brief, and here we can see that faster Ethernet 0/1 is up, Also 0/6 also up. Configure terminal. We'll go to the interface as a range. Fast Ethernet 0/2 till 5. Also Fast Ethernet 0/7 till 24. Also 2 gigabit Ethernet G0/1 and 2. We will give shutdown command here. Coming to switch S2, here we can see we used 3 ports. Fast Ethernet 0/1, 0/11 and 0/18. We can verify that using the show command, show IP interface brief, and here we can see those interfaces 0/1, 0/11 and 0/18. So we are going to shut down all other interfaces except these 3. Configure terminal, interface range Fast Ethernet 0/2. We will go till 10. Then we have Fast Ethernet 0/11. No, 11 we have to exclude, so 12 till 17. Also we have Fast Ethernet 0/19 till 24. Also we have 2 gigabit Ethernet ports G 0/1 and 2. Here we are going to shut down these ports. Coming to F, copy the running configuration to the startup configuration. Coming to S1, copy running config, startup config. Coming to S2, copy running config, startup config. Now we will come to step 4, configure PC host. Refer to the addressing table for PC host address information. Coming to our addressing table, here we can see PC devices and its IP addresses. Coming to PC-A, desktop IP configuration. Here we can see the IP address. We'll copy that. Then the subnet mask, also the default gateway. Then coming to PC-B, desktop IP configuration. Here is the IP address, also the subnet mask. Here is the default gateway. Coming to PC-C, here is the IP address, subnet mask. Here is the default gateway. Now we will come to step 5, test connectivity. Verify that the PC hosts can ping one another. They're given a note also. It may be necessary to disable the PC's firewall to ping between PCs. If you are using the real PCs, so we must disable this PC's firewall. Can PC-A ping PC-B? We have to check that. We will get the IP address of PC-B. Here is that. We will copy this. Coming to PC-A, command prompt, and here we are going to ping to PC-B, and here we can see we are getting the reply. Yes, it's pinging. Next is can PC-A ping PC-C? We will check that. Coming to PC-C, and we will get the IP address. Coming back to PC-A, command prompt, ping to PC-C. Here is the address, and we are waiting for the replay. Request timed out. No, here we are not getting the replay from PC-A to PC-C. No. Next is can PC-A ping S1? We will get the IP address of S1. Here is that. Coming to PC-A, command prompt ping to S1. We are waiting for the replay. Request timed out. It's not communicating because they are in different networks. No, it's not. So here the answer is no. Next is can PC-B ping PC-C? We will get the IP address of PC-C. Coming to PC-B, command prompt ping to PC-C. Here also we are not going to get the replay. Request timed out. No, we are not getting the replay. Here the answer is no. Can PC-B ping S2? Coming to PC-B, and we will ping to S2. Ping to S2, here is the IP address. It's not going to work. Request timed out. No, we are not getting the replay. No. Next is can PC-C ping S2? Coming to PC-C, and we will try to ping to S2. Here is the address. It won't work. Request timed out. No, it's not pinging. Can S1 ping S2? We will check that. Coming to S1. Cisco enable password class. Ping to S2. Here is the IP address. Here we can see success rate is 60%. It's communicating because they are the same network. Yes. If you answered no to any of the above questions, why were the pings unsuccessful? Already I told, here we got some of the unsuccessful pings. Here we can see this PC-A and the PC-B are in the same network, S1 and S2 in the same network. So these S1 and S2 will communicate, PC-A and the PC-B will communicate. But we can see PC-A and the PC-C won't communicate because they are in different networks. Even PC-C to S2 or PC-C to S1 or PC-C to these two devices also it won't communicate. Now we will come to part 2, create VLANs and assign switch ports. In part 2 we will create student, faculty and management VLANs on both the switches. We will then assign the VLANs to the appropriate interface. The show VLAN command is used to verify our configuration settings. Coming to step 1, create VLANs on the switches. A. Create the VLANs on S1. Here we can see the command what we have to give. We will do that on S1. Coming to the switch S1. Configure terminal VLAN 10. Name as a student. Now we'll create VLAN 20. Name as a faculty. Then VLAN 99. Name as management. Coming to B, create the same VLANs on S2. Coming to S2. Password Cisco, enable password is class. Configure terminal VLAN 10. Name as a student. VLAN 20. Name as a faculty. VLAN 99. name as management. Coming to C, issue the show VLAN command to view the list of VLANs on S1. Here itself they given the output for show VLAN. Here we can see the VLANs what we created: 10 student, 20 faculty and 99 management. We will give this command on our switch S1. Coming to S1, privileged exec mode, we are going to give a show VLAN, and here we can see the details. Here is the VLANs of what we created. What is the default to VLAN? Here we can see the default to VLAN. It's a VLAN 1. Then what ports are assigned to the default to VLAN? Here we can see all the ports is assigned to this VLAN 1. Now we will come to step 2. Assign VLANs to the correct switch interfaces. A. Assign VLANs to the interfaces on S1. Assign PCA to the student VLAN. Here we can see how we have to assign it. We have to change the mode to access. We will do that. Coming to the switch S1. Configure terminal. We will go to the interface fast Ethernet 0/6. Switch port mode as access. Switch port access VLAN 10. Coming to 2, move the switch IP address VLAN 99. So we have to go to that interface VLAN 1 and we have to remove the IP address, and we are going to assign that IP address to this VLAN 99. We will do that on S1. We will exit and we will go to the interface VLAN 1, and here we are going to give a no IP address. Now we will go to the interface VLAN 99, and here we are going to set the IP address 192.168.1.11, and the subnet mask 255.255.255.0. Coming to B, issue the show VLAN brief command and verify that the VLANs are assigned to the correct interfaces. Show VLAN brief. Here we can see this port fast Ethernet 0/6 is assigned to VLAN 10 named student. We will verify that on our switch S1. Show VLAN brief, and here we can see that fast Ethernet 0/6 is assigned to VLAN 10 student. Coming to C, issue the show IP interface brief command. What is the status of VLAN 99 and why? Coming to S1, here we are going to give the show command. Show IP interface brief, and we will verify the VLAN 99 status. Here we can see VLAN 99 IP address is assigned. Here we can see the status is up, but here we can see the protocol is down. Why this protocol is down here? Coming to our previous show command, that is show VLAN brief. Here we can see no ports are assigned to this VLAN 99. That's why it shows this protocol shows down. Coming to D, use the topology to assign VLANs to the appropriate ports on S2. Coming to the switch S2, here we can see the used ports. Fast Ethernet 0/11, here we can see we have to assign to VLAN 10. Also we can see fast Ethernet 0/18, we have to assign to VLAN 20. Coming to the switch S2, Configure terminal. We will go to this interface fast Ethernet 0/11. Interface fast Ethernet 0/11. Switch port modus access. Switch port access VLAN 10. Now we will go to this interface fast Ethernet 0/18. Interface fast Ethernet 0/18. Switch port mode as access. Switch port access VLAN 20. Coming to E, remove the IP address for VLAN 1 on S2. Also configure an IP address for VLAN 99 on S2 according to the addressing table. So we will come to our addressing table. Here is that we can see the IP address. Here they are given for this interface VLAN 1, so we will remove that. Configure terminal interface VLAN 1, no IP address. Now we will assign this IP address for the interface VLAN 99. We will go to the interface VLAN 99 and here we are going to give IP address. Here is the address. Subnet mask 255.255.255.0. Coming to G, use the show VLAN brief command to verify that the VLANs are assigned to the correct interfaces. Giving this show command, show VLAN brief. Here itself they given the output. Here we can see this port fast Ethernet 0/11 is assigned to VLAN 10. Then the fast Ethernet 0/18 is assigned to VLAN 20. We will verify that. Coming to our switch S2. Show VLAN brief. And here we can see the details. Here we can see the port fast Ethernet 0/11 is assigned to VLAN 10. Then the port fast Ethernet 0/18 is assigned to VLAN 20. It's correct. Is PC-A able to ping PC-B? Why? We are going to ping from PC-A to PC-B. Both are in the same VLAN. We will try that. We will get the IP address of PC-B. Coming to PC-A, desktop, command prompt. Here we are going to give ping to PC-B. Request timed out. No, we are not getting the reply. Here the answer is no, because we have to configure an 802.1q trunk between these two switches, that is S1 and S2. Next is S1 able to ping S2? Why? We will try that. Coming to the switch S1, CLI. Ping to S2. Here is the IP address of S2. And we are waiting for the reply. It's not going to ping. Here we can see success rate is 0%. So here answer is no. Why it's not pinging? So here are the IP addresses for the switches we given in VLAN 99. And VLAN 99 traffic will not be sent over this link fast Ethernet 0/1 until we set this link between S1 and S2 as a trunk. Now we will come to part 3, maintain VLAN port assignments and the VLAN database. In part 3 we will change VLAN assignments to ports and remove VLANs from the VLAN database. Step 1, assign a VLAN to multiple interfaces. Here we can see on S1 assign interfaces fast Ethernet 0/11 hyphen 24 VLAN 10. Here we can see that command. We will go those interfaces as a range, and we are giving switch port mode as access, switch port access VLAN 10. We will do that. Coming to the switch S1, configure terminal interface range fast Ethernet 0/11 till 24, switch port mode as access, switch port access VLAN 10. Coming to B, issue the show VLAN brief command to verify VLAN assignments. Coming to S1, show VLAN brief, and here we can see the details. Here we can see now from fast Ethernet 0/11 till 24, now it's in VLAN 10, including this port fast Ethernet 0/6. Coming to C, reassign fast Ethernet 0/11 and fast Ethernet 0/21 to VLAN 20. So we are going to assign these two ports to VLAN 20 on S1. Coming to S1, configure terminal interface. We will go as a range fast Ethernet 0/11 comma fast Ethernet 0/21. Switch port access VLAN 20. Coming to D, verify that VLAN assignments are correct. Coming to the switch S1, and we will verify that by giving this a show VLAN brief command. And here we can see now these two ports are removed from the VLAN 10 and it's assigned to VLAN 20. Coming to step 2, remove a VLAN assignment from an interface. Use the no switch port access VLAN command to remove the VLAN 10 assignment to fast Ethernet 0/24. Here we can see the command. Interface F0/24 no switch port access VLAN. We will do that. Coming to the switch S1, configure terminal interface fast Ethernet 0/24 no switch port access VLAN. Coming to B, verify that the VLAN change was made. So coming to S1, here we are going to give the command show VLAN brief, and now we will check the interface fast Ethernet 0/24 will belongs to which VLAN. Here we can see that fast Ethernet 0/24, we can see it belongs to the default VLAN now, VLAN 1, because we removed from VLAN 10. Which VLAN is fast Ethernet 0/24 now associated with? It's VLAN 1. Now we will come to step 3, remove a VLAN ID from the VLAN database. A, add VLAN 30 to interface fast Ethernet 0/24 without issuing the VLAN command. Here we can see that. Coming to S1, configure terminal interface fast Ethernet 0/24 switch port access VLAN 30. Here we can see access VLAN does not exist, creating VLAN 30, right? Because we did not create this VLAN 30, now it's created. Yes, here we can see that message. They given a note regarding this. The current switch technology no longer requires that the VLAN command be issued to add a VLAN to the database. By assigning an unknown VLAN to a port, the VLAN adds to the VLAN database. So that's why here they shown the message. It's created this VLAN 30 automatically. Coming to B, verify that the new VLAN is displayed in the VLAN table by giving this show VLAN brief command. Here we can see that now VLAN 30 is added with a default VLAN name, and here we can see this port fast Ethernet 0/24 is assigned to this VLAN 30. We will check it on our switch S1. Show VLAN brief, and here we can see VLAN 30 with the VLAN default name for this VLAN 30. And here we can see this port fast Ethernet 0/24 now is assigned to this VLAN 30. What is the default name of VLAN 30? So there we have seen that. Here we can see VLAN 0030. Coming to C, use the no VLAN 30 command to remove VLAN 30 from the VLAN database. No VLAN 30. Coming to S1, configure terminal no VLAN 30. Coming to D, issue the show VLAN brief command. Fast Ethernet 0/24 was assigned to VLAN 30. Yes, it's correct. So after deleting VLAN 30, what VLAN is port fast Ethernet 0/24 assigned to? What happens to the traffic destined to the host attached to F0/24? Coming to the switch S1. Here we are going to give a show VLAN brief. And now we can see the VLAN 30 is removed, and here we cannot see the port fast Ethernet 0/24. That means that port is not assigned to any VLAN, and this port will not transfer any traffic. Here also we can see the output for the show command, show VLAN brief. Issue the no switch port access VLAN command on interface fast Ethernet 0/24. Coming to S1, configure terminal interface fast Ethernet 0/24, and here we are going to give the command no switch port access VLAN. Coming to F, issue the show VLAN brief command to determine the VLAN assignment for F0/24. To which VLAN is F0/24 assigned? Coming back to S1 again, show VLAN brief, and now we can see the port fast Ethernet 0/24 is assigned to the default VLAN 1. So it's VLAN 1, and here they given a note: before removing a VLAN from the database, it is recommended that you reassign all the ports assigned to that VLAN. Here we have a question: why should you reassign a port to another VLAN before removing the VLAN from the VLAN databases? So previously we have seen that the interfaces assigned to a VLAN that is removed from the VLAN database are unavailable and will not send the traffic until they are reassigned to another VLAN. That's why we say reassign a port to another VLAN before removing the VLAN from the VLAN database. Now we will come to part 4, configure an 802.1q trunk between the switches. In part 4, we will configure interface F0/1 to use the dynamic trunking protocol, that is a DTP, to allow it to negotiate the trunk mode. After this has been accomplished and verified, we will disable DTP on interface F0/1 and to manually configure it as a trunk. Coming to step 1, use DTP to initiate trunking on fast Ethernet 0/1. The default DTP mode of a 2960 switch port is dynamic auto. This allows the interface to convert the link to a trunk if the neighboring interface is set to trunk or dynamic desirable mode. So set F0/1 on S1 to negotiate trunk mode. Here we can see the command. Coming to S1. Configure terminal. We have to go to the interface. Fast Ethernet 0/1. Switch port mode dynamic desirable. Here we can see the messages. You should also receive a link status message on S2. So here we can see that those messages. Coming to B, issue the show VLAN brief command on S1 and S2. Interface fast Ethernet 0/1 is no longer assigned to VLAN 1. Trunked interfaces are not listed in the VLAN table. So we are going to give this command show VLAN brief. Coming to our switch S1. Okay. Class show VLAN brief. Coming to the output. Here we can see now this port F0/1 is no longer assigned to this VLAN 1. Coming to C, issue the show interfaces trunk command to view trunked interfaces. Notice that the mode on S1 is set to desirable and the mode on S2 is set to auto. Coming to S1 again, here we are going to give show interfaces trunk, and here we can see the details. Here we can see the mode desirable. Port is F0/1. Coming to S2. Show interfaces brief. Not brief, here we have to give a show interfaces a trunk. And here we can see the mode is auto. Port FA0/1. They given a note here. By default, all VLANs are allowed on a trunk. The switch port trunk command allows you to control what VLANs have access to the trunk. For this lab, keep the default settings which allows all VLANs to traverse F0/1. Now coming to D, verify that VLAN traffic is traveling over trunk interface F0/1. Can S1 ping S2? We have to check that. Coming to S1, and we will ping to S2. Here is the IP address. Success rate is 60%. Yes, it's working. Yes, now we able to ping. Can PC-A ping PC-B? It should work. We will get the IP address of PC-B. Then coming to PC-A, command prompt, and we will give a ping to PC-B, and here we can see we are getting the replay. Yes. Next is can PC-A ping PC-C? We will get the IP address of PC-C. Here is that. It won't work because they are in different VLAN. Coming to PC-A, command prompt, ping to PC-C. Request timed out. No, it's not. No. Next is can PC-B ping PC-C? From PC-B to PC-C. To won't work. Here itself we can see PC-B is in VLAN 10. PC-C is in VLAN 20. We can make it possible to ping. We have to keep a router and we have to configure inter VLAN routing. Anyways, here it's not going to work. We will check that. We will get the IP address of PC-C. Coming to PC-B command prompt, ping to PC-C. It's not working. No. Next is can PC-A ping S1? From PC-A to S1, it won't work because this PC-A is in a 10.0 network and this S1 we configured as a 1.0 network. They are in different networks, so it won't communicate. Anyways, we will check that. Command prompt, ping to 192.168.1.11. No, it's not. Can PC-B ping S2? Same like previous case, it won't communicate from PC-B to S2 because they are in different networks. Ping to 192.168.1.12. No, it's not. Can PC-C ping S2? Here also no, because we can see PC-C and S2, they are in different networks. Anyways, we will ping and we will check it. Ping to 192.168.1.12. Here is the result. If you answered no to any of the above questions, explain below. So here itself we explained why it's not pinging. Now we will come to step 2. Manually configure trunk interface F0/1. The switch port mode trunk command is used to manually configure a port as a trunk. This command should be issued on both ends of the link. Coming to A, change the switch port mode on interface F0/1 to force trunking. Make sure to do this on both switches. We will do that on our switches. First of all, we will do it on S1. Configure terminal interface fast Ethernet 0/1. Switch port mode as a trunk. Now we will go to S2. Configure terminal interface fast Ethernet 0/1. Switch port mode as a trunk. Coming to B, issue the show interfaces trunk command to view the trunk mode. Notice that the mode changed from desirable to on. Right, so we will give this command. Show interfaces trunk. Here we can see the mode is on. Coming to S2. Here we can see the mode is on. But here in this show interfaces trunk command, here we can see the native VLAN what they shown here is 99, but previously they shown it's 1 because we did not set the native VLAN. It's by default it's 1. Here we can see that now we are in native VLAN 1 on both switches. Right. So why might you want to manually configure an interface to trunk mode instead of using DTP? Yes, here the reason is not all equipment uses a DTP. So here using the command switch port mode trunk, ensure that the port will become a trunk. Now we will come to part 5, delete the VLAN database. In part 5, we will delete the VLAN database from the switch. It is necessary to do this when initializing a switch back to its default settings. Coming to step 1, determine if the VLAN database exists. Issue the show flash command to determine if a VLAN.dat file exists in flash. So we are going to give this command, and here we can see the file VLAN.dat. They given a note also, if there is a VLAN.dat file located in flash, then the VLAN database does not contain its default settings. Coming to our switch ES1, here we are going to give the command show flash, and here we can see the file VLAN.dat. Now we will come to step 2, delete the VLAN database. Issue the delete VLAN.dat command to delete the VLAN.dat file from flash and reset the VLAN database back to its default settings. You will be prompted twice to confirm that you want to delete the VLAN.dat file. Press enter both times. So we will give that. Coming to ES1, here we are going to give delete VLAN.dat, delete file name VLAN.dat, press enter. So again they are confirming, again we have to press enter. Coming to B, issue the show flash command to verify that the VLAN.dat file has been deleted. We will give that. Show flash. Now here we cannot see the file named VLAN.dat. It's deleted. Coming to this question, to initialize a switch back to its default settings, what other commands are needed? So we required two more commands. One is erase startup config, then a reload. Coming to the reflection questions, first one, what is needed to allow host on VLAN 10 to communicate to host on VLAN 20? This is already we discussed. We have to keep a layer 3 device such as a router or a layer 3 switch. Coming to the second question, what are some primary benefits that an organization can receive through effective use of VLANs? Some of the benefits are better security, cost saving, higher performance, smaller broadcast domains, also broadcast storm mitigation. Well, that's all in this lab activity, that is configuring VLANs and trunking. Friends, if you have any doubt in this lab activity, please comment below. Also, if you like my video, give a thumb and share with your friends. And don't forget to subscribe the channel so that you will get latest uploading video info into your Gmail. Thank you.